Okay, so we are going to begin talking about parabolas. So the first thing we want to talk about is what equations you might be given on the final. You will most definitely be given this top equation, which gives you the general or standard form, vertex form of the equation. I'm not sure if we're going to be giving you anything more than that, so you might have to realize how this 1 over 4a works. That's the direction of your that you are from the vertex to the focus, and that will play a part in knowing how to come up with your equation. You also then should just be aware if your graph is going up like this, that's the y equals, that's your first equation, and that would be when a is positive. If your graph is going down, if it's a frown, then your a is negative. The second equation is going to be x equals. That gives you the sideways graph. So if your graph is going in this direction, that meant a was positive. It's going in the positive direction. If your graph is going sideways towards the negative direction, that's when your a is negative. So it's going to be important that you just know those because those will not be given to you. Now, what I'd like to do, I'm going to try and make some space here, and we're going to work out this little problem together. So it gives you, write the equation of a parabola in standard form, identify the vertex, focus, and equation of the directrix. There is a typo here. One of these y's should be an x. Okay, so what we're going to need to do is we're going to need to complete the square on that. So what I'm going to do is organize. Always put all my x's together. So I have x squared plus 4x plus, I'm going to have a blank, and that's going to equal, I'm going to move to the other side, my negative 4y, and add 8. So now we can go through and complete the square. So we want to ask ourselves, half of 4 squared is what? So I'm adding 4 to both sides, and that's now going to allow me to complete the square on this. So this is going to become x plus the square root of 4 is 2 squared, and that is going to equal negative 4y plus 12. So we want to put it in standard form, which means that y is isolated. So this is going to be a two-step process. The first step is to subtract 12 from both sides. So that gives us x plus 2 squared minus 12 equals a negative 4y. And the next step now is to divide through by a negative 4. So you have to divide both terms by the negative 4. So simplifying it, that gives me a negative 1/4 x plus 2 squared plus 3, negative 12 divided by a negative 4, equals y. So that is your standard form for the parabola. So to graph it from that, that means I would have a vertex at negative 2, positive 3. So negative 2, 1, 2, 3. So there's my vertex. Because it's y equals, but that's a negative 1/4. The negative says I'm going to go down. So there's my graph. Now we have to find, so they want the center, the vertex. So we know the vertex. Our vertex is, always take the opposite of what's in the parenthesis and exactly what is outside. So negative 2, 3. We have to find the focus and our directrix. Okay, so here's where the 1 over 4a comes in. The distance, your focus would be down here somewhere, and your directrix is going to be back here somewhere. That's just traditionally where they are always going to be placed. The distance to that focus is 1 over 4 times a. Well, we happen to know what a is. This number right here is a. So we have 1 over 4 times a negative 1/4. That means that distance is a negative 1. From the vertex, I'm going down 1 unit. So since I was at negative 2 on the x, from the y, I came down 1, so I'm now at negative 2, 2. To go up to your directrix, you go back or up 1 unit. So they're both the same distance from the vertex, and that's going to be the equation of a line. So it's the equation y equals, so from 3 I went up 1, So that's going to be y equals 4. Okay? So that is how you would work out the equation of your conics. Now we are going to work on the circle. So when you're doing a circle, notice you have a distance formula, a midpoint formula. You will definitely be given the circle formula. One of the teachers doesn't want you to have the distance and midpoint formula, so you're going to need to know that. So for the circle problem, if I give you 2 points, -4, 8, and the point 12, 2, those are the endpoints of the diameter. So in order to find the center of my circle, my HK, what I'm going to need to do is find the midpoint. So you find the midpoint by adding the two numbers, so 12 plus a -4, and dividing by 2. I take 8 plus 2 and I divide by 2. So 8 divided by 2 is 4, 10 divided by 2 is 5. That is going to be the center of my circle. We call that center HK. So far I know that x minus 4 squared plus y minus 5 squared is going to equal r squared. What I don't know is r yet. So one thing you can do is take one of your points. Since I know this is the endpoint of a diameter, I know it's on the circle, it satisfies this equation. So the distance from a point on the circle to the center is your radius by definition. So I'm going to plug this point into, for x, I have a 12 minus 4 squared plus, for y, we have 2 minus 5 squared, and find out what that equals. So that's going to be 8 squared plus 3 squared, so 64 plus 9 is 73. That does equal r squared. So then I come up here where we had an r squared, and we're going to substitute in 73. And that is then the equation of the circle. Okay, so now we're going to talk about ellipses. So the important thing to remember with an ellipse is that a is the bigger number in the denominator, which means it's the major axis. So in this first one, if a is under the x, your ellipse is going to be going in this direction. If a is under the y, then your graph, your ellipse, is going more in the vertical direction. And in general, vertices are all, ellipses and hyperbolas, it's all about finding a, which is the distance from the center to a vertex, b, which is the little one, and also c, which is the distance to your foci. So this would be c, and so this would be a point where your foci is. So if you can identify HK, which is your center, A, B, and C, you can write the equation. So let's go through and do that for this particular problem. So it says, write the equation of the ellipse in standard form given the vertices 8, 2, 2, 2, and foci 7, 2, 3, 2. So first thing I do, because I read that and it's like, yeah, whatever, I go through and I'm going to do a graph. So I know that I'm going to be at 8, 2. So here, let's call this out 8 and up a distance of 2. There's 8, 2. And I'm out here at 2, 2. So those are the endpoints of my vertices. So that's going to be my major axis. I don't know exactly what it looks like, but let's just go ahead and draw that in. Okay. What that tells me is from 2 to 8, that is a distance of 6. So I know that my center is half that distance. This distance is going to be 3 in. So adding the 3 to 2 puts me at 5. Or you could do again a midpoint. 8 plus 2 is 10, divided by 2 is 5. So I know that my HK, the center of my ellipse, is going to be at the x value is 5, and I'm up at a height of 2. Okay? Now let's plot the second point they give us. They give us that your foci is at 7, 2, so that's going to be right inside here, and at 3, 2, so this is out here at 7, and this is in here at 3. So what are we going to gain from this? So I know that this distance, this is a distance of c. So I know that c is going to be a distance of 2. I know that a, because A is the distance out to the vertex from 5 to 8. That's a distance of 3. So the big question is, what is B? All right, so let's start to write our equation. Because the longer or major axis is in the x direction, I'm going to be working off of this formula. X minus h squared over a squared, because that's the major, y minus k squared over b squared equals 1. You always set your ellipses and hyperbolas equal to 1. So this is nice. We already know that h is going to be 5, so we'll plug that in. And we already know that our k is going to be 2, so we can plug that in, equals 1. We already know that a is 3, so we know that this will be 3 squared is 9. And the big question mark is, what is b? So here's where we're going to go use this formula down here that gives the relationship. We know that a squared minus b squared equals c squared in an ellipse. So I know that 9 minus b squared is going to equal c squared, which is 4. So 9 minus what is 4? We know then that b squared has to equal 5. 9 minus 5 is 4. And in reality, I don't care what b actually is, because what goes here is b squared. So there is my equation, and in the process, we already have a graph. Okay? So now we're going to do hyperbolas. So what you want to realize, it's not about bigger and smaller now, it's about positive and negative. So if your x term is the positive, that means our hyperbola is going to be going off in the x direction. If your y term is the positive, that means the branches of your hyperbola are going up and down vertically in the y direction. Okay, and then again you have this relationship. So it's really about finding h, k, a, b, and c. Now in this particular problem, it comes to you and we're going to need to complete the square twice. So what we're going to do is we're going to organize our information. So we take our x values. We have x squared minus 4x plus blank. Now for the y terms, because it has a coefficient, I'm going to factor out the minus 4. So I have y squared. The negative 8 becomes a positive 2, because negative 4 times 2 is a negative 8, plus blank, because I'm going to be completing the square on this. Close my parentheses, equals, I'm going to add 16 to the other side. I'm also going to be adding something for this term here, and I'm going to be subtracting 4 times something, whatever goes in here, because that's negative 4 times that amount. So what do we put in there? Well, half of 4 squared is 4, so that 4 is going to go there. Here, half of 2 squared is 1. So notice I have a negative 4 times 1, so that's negative 4. So now we can complete the square on this. We have this is going to be x minus 2 squared minus 4 times y plus 1 squared equals, notice the 4's will cancel, 16. But with an ellipse, you're always setting your equation equal to 1. So we have to divide everyone through by 16. So our final equation is going to look like x minus 2 squared over 16 minus y plus 1 squared over 4, because 4 goes into 16 4 times, and that all equals 1. So there's my equation in standard form. Now if I was going to graph it, you are going to want to set up your xy axis. My center is going to be at 2, negative 1. So there's my center. In the x direction, I'm going to go the square root of 16 forward and back. So 1, 2, 3, 4 puts me out here, and 1, 2, 3, 4 puts me back here. And then in the y direction, I'm going to go up 2, 1, 2, and down 2, 1, 2. And that tells me where to draw the box. And then if we do the diagonals through the box, those are your asymptotes. Since the x term was positive, my hyperbola comes off the box in the x direction. That is going to be the graph. So let's see what they want. The center, going back, is going to be 2 comma negative 1. My vertices, and again that's only where the parabola is drawn. Again, remember we went out a distance of 4 from the center. So we went 2 plus 4, so that's at 6 negative 1. And we went 2 minus 4, so that's negative 2 minus 1. So we went forward and backwards a distance of 4. And they want the foci. Okay. So your foci, you're going to use your a squared plus b squared equals c squared. So notice here it's 16 plus 4, because that's a squared, plus b squared. That's going to equal c squared, which is 20. So we know that c is going to be the square root of 20, which is 2 rad 5. And again, so your foci exist right inside the folds. So this is like foci 1, foci 2. So from the center in the x direction, you're going to go 2 plus or minus that square root of 20, and then you still are at negative 1. So there's your answers for all the information that they wanted right here. Okay? There's your conic sections in a nutshell.